Hello there, this is Professor Eckhouse, and I am talking today about section 1.5, dividing whole numbers. So here are all of the objectives that I'm going to talk about right now, so this is probably going to be a little bit longer video. All right, so starting with symbols that represent division. There are 4 different things that we're going to talk about here. We've got the divide sign, and we've got the fraction bar, and I just want you to notice how similar these are. Where do you think the divide sign came from? Looks just like it. So the other one is not very well typeset here, but our typical division sign like you learned way back in elementary school. And then some people use a slash. I don't do that very often because I find it to be a little bit confusing when I write for people. So I usually use this version if I'm going to do a slash or a bar. All right, so for all of these, we say 12 divided by 4, and we can also call it the quotient of 12 and 4. So when we say the quotient of, the order of the numbers is the order that they are divided. So the quotient of 12 and 4 would be 12 divided by 4. All right, so let's look at a few examples. Translate from math notation to words. So 64 divided by 8. Okay, so I'm not going to write all of these down. You can repeat by rewinding if you need to. Number 1 here is 64 divided by 8. It is the quotient of 64 and 8. The next one is 42 divided by 7, or the quotient of 42 and 7. And the last one here, I'll use my highlighter instead, is 28, and I am going to write this one down. I want you to see 28 divided by 4, not 4 divided by 28. It's 4 into 28. So some people will say 4 into 28, but it's really 28 divided by 4. So you have to be careful with the words and what order the numbers are actually being divided, just like subtraction. Okay, so model division of whole numbers. So model this division. So I'm not getting a lot into modeling. There's a lot of it in the book, and you can look. But we're going to show the way you model division. Notice this isn't an area model. It's just like random things here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'll go like that. And then 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to have that one. And then hopefully 1, 2, 3, 4, 5, 6, 7, 8. There we go. How many sets do we have? We have 3 sets. So that equals 3. All right, so dividing and checking. So checking is one thing that people don't do very often, and I want to show you how to do this. So 42 divided by 6 equals 7. Okay, so the way we check, and this is going to be my check, that arrow right here is going to be how I'm saying that I'm checking. We're going to take the 7 and multiply it back to the 6 and make sure we get 42. So 7 times 6 equals 42. Okay, so that's how we're going to do it every time. 72 divided by 9 equals 8. I'm going to check. And so I've got 9 times 8. So 9 times 8. And of course you could say 8 times 9, it doesn't really matter, is 72. And the last one, be careful, write it in the right order. 63 divided by 7 is 9, or you could still write it just like that and put the 9 up on top if you'd like. And we're going to check this by multiplying the 7 and the 9, and we get 7 times 9 in any order equals 63. So all of these check. All right, division properties. Division properties of 1. So there's 2 different division properties. Any number except 0 divided by itself is 1. Okay? And any number divided by 1 is itself. All right, so let's check those. This would be our check over here, right? So we're going to take this one times this one. A times 1 equals A. Well, yep, sure enough. We're trying to get this original number right here. And then 1 times A. 1 times A equals A. Again, trying to get the original number. They both check. Okay? So if it helps it to make sense by thinking about it as multiplication, that's my goal here, is to help things make sense to you. All right, so example 4 is just the exact same thing that we just did. So we've got 11 divided by 11 equals 1. And if we are going to check, it would be 1 times 11 equals 11. Yep, that checks. The next one I'll do down here, number 2. We've got 19 divided by 1 is 19. And let's check it by using these two numbers here. We get 1 times 19 is 19, and it checks. Number 3, we've got 7 divided by 1 is 7. We check by saying 1 times 7 is 7. Okay, so that's all they're asking you to do right there. It's very straightforward. The division property of 0. All right, so the division property of 0, this is something you need to understand because a lot of people get this messed up. I'd say on problems in the homework, I've seen more than half the people get these problems wrong. So it seems so simple when I explain it, but you just have to remember, and I'm going to show you the why. So 0 divided by any number, our number is going to be a, is 0. Well, let's check that. Let's check it and see what happens. So we get a times 0 equals 0. Sure enough, anything times 0 is 0. So great. Well, we've got a divided by 0 is undefined. Well, why isn't it 0? So let's check and see why it isn't 0. So let's do it wrong. Let's do it wrong. And let's say that a divided by 0 equals 0. Well, that would mean then if we were going to check this, we were going to check it, it would be 0 times 0 equals a. No way. That's not true. 0 times 0 doesn't equal a number. 0 times 0 is 0. So that is why this is undefined. And there are other philosophical ways to think about it, like how many zeros do you have in an A? Well, infinite. So it doesn't really make sense. So it's undefined. Okay? So let's look at some examples of that. So take a pause in the video and see if you can answer these. Are you going to get them right? All right, so 0 divided by 3, or divided by anything, is 0. 10 divided by 0, anything divided by 0 is undefined. Okay, undefined. So that when you go to do the Lumen homework, you will write does not exist, D-N-E, in Lumen. All right, the division algorithm and vocabulary you need to know. Okay, so when we talk about division, we've got the dividend divided by what we call the divisor, and the thing that it equals is the quotient. So I have color-coded all of these in 3 different ways. So we're using the division symbol, using the other division symbol, and using the fraction bar. Okay, so the purple one is the dividend. The green one is the divisor. And the orange one is the quotient. The answer is the quotient. The thing we're dividing into is the dividend, the purple. And the thing we're dividing by is the divisor, that's green. What if it doesn't divide perfectly? So let's look and see what happens. So 22 into 263, I'm going to do the division algorithm here. And we're going to look at the what we call everything. Okay, so we're going to say 22 times 1, and we're going to subtract here, and we get 4. Bring down the 3. 43. How many times is 22 going to 43? It does not go in twice because that would be 44. So it just goes in once. So 22, subtract, and we get 21. So what is all of this called? What is all of this called? So I'm gonna change my 11 to be orange so that this follows our colors. Okay, so the green is the divisor. All right, the orange is the quotient. The purple is, think about it, what is it? The dividend. And the thing sitting down here is the remainder. So when you divide 263 by 22, you get 11 with a remainder of 21. So how would we check this by multiplying? I'm not going to worry about my colors because it's just too much. So we check this by multiplying by going like this. 11 times 22, the quotient times the divisor, just like we were checking up above, and I get 242. What about the remainder though? So we're going to take the remainder and we're going to add it back in. Okay, we're going to add that back in and we get 263. Was that our dividend? Yes, it was. So this checks. So this is what the try it problems from your book and from the homework look like. And you need to know how to do these and what to fill in. So what they're asking you for here is that number up on top, the quotient, right? The quotient. So this is the quotient right here. And then the R stands for remainder, right? Remainder. And these are the ones in your book. You can have it show you the answer. You can try it and then submit it and it'll tell you if you're right. You can try another version of the question and that kind of thing. All right, so we would take 800 and divide it by 14. Now, if you put this in your calculator, you're not going to get the answer because you're going to get a decimal point, and that does not give you a remainder. So you're going to take 14. How many times does 14 go into 80? It goes in 5 times with a little remainder. So 14 times 5, you can put that in your calculator if you want to make this faster, is 70. And I get 100 because I'm going to take that 0 down. So now how many times does 14 go into 100? You can check it on your calculator to try. 14 goes in 7 times. 7 times 14 is 98. And my remainder is 2. Okay, so what they want here is they want 57 with a remainder of 2. That's what they're looking for. I have some very active birds outside the window. I don't know if you can hear that, but okay, so the last thing we're going to work on here is translating word phrases into math notation. Okay, so things that signify division, divided by, of course. Quotient of, we've already talked about. Divided into, you take the numbers and you switch them, right? Divided into and divided by are opposite of each other. You'll also see the word per. Per is like there are 25 birds per every 2 trees outside my window, right? So that's per is division, 25 divided by 2 to find how many birds are in every tree. All right, so how would you write the following in math notation here? So 12 divided by 3. So you can write this as 12 divided by 3, or you can write it as 12 over 3, or you can write it as 3 into 12, like that, 12 divided by 3. The quotient of 5 and 7. So that means 5 divided by 7. You have to do it in the right order. Or you can do 5 divided by 7, or you can do 7 into 5, or 5 divided by 7, if you don't read left to right. 5 divided by 7. All right, the next one, 12 divided into. Be careful. What this is saying is 37 is being divided by 12. Okay, so 37, I think it's a very awkward way to say it, but sometimes you'll see it. So 37 divided by 12, or you can, this one actually makes more sense written this way, 12 divided into 37. All right, so let's practice this in an application. So remember, to determine what you're looking for, write a phrase that helps you find it or say it in your head, okay? I also draw pictures. Translate it to math notation and then simplify it. Answer it as a sentence so it makes sense. Okay, so answer at least in your head, in a sentence. All right, so to save money and reduce waste, Frances bought a giant box of crackers with the plan to divide them into small bags and take to school with her every day. That's smart. The box contains 48 ounces of crackers. So now we're going to answer some questions. How many 2-ounce bags can she make out of that big bag? Okay, so what math are we going to do here? So let's look at number 1. We've got this big bag that's got 48 ounces, and we want to divide it into 2-ounce containers. 2-ounce containers. Now, if you look at some videos, they've got some fancier pictures, much fancier pictures, right? Where they actually divide this into 2 ounces, 2-ounce containers. Okay, so dividing it into, how many does it divide into? Well, you're going to have to do the division to figure that out, right? So 48 divided by 2. 48 ounces divided by 2 ounces is going to tell us how many 2-ounce bags we have, and that's going to be 24 2-ounce bags. Make sure it makes sense. If you got 140, it would not make sense, right? So just think about it. All right, let's see. The second one, if there are 150 calories in a 1-ounce serving, how many calories are in a 2-ounce serving? So basically, another way to think about this is with a picture. Here we've got a 2-ounce serving. So this is 2 ounce, and we want to know how much is in each 1-ounce serving. If there are 150 in each 1-ounce serving calories, right? Hopefully you can see that it's going to be 150 times 2 for 300 calories in a 2-ounce serving. Okay. All right. That's it. Thank you for watching.